Yes, sir.
Patel. Okay, nice. Are you able to see my screen clearly? Okay, good. Wait for a few minutes. I will start. So let we should wait for others. They will join. We will start.
ठीक है इन्होंने फिर पता नहीं क्या काम करा पता
So let's start. In the last class, we have discussed about the lubricants, how the additives play an important role in the performance of lubricants. So we have discussed various kind of lubricants, like they have to work like antioxidant, detergent, anti-wear, metal deactivators, corrosion inhibitor, friction modifier, extreme pressure, anti-foaming agents, and viscosity index improver, demulsifying agents, and stickiness improver. So they are the 10 or 12 listed properties that the additives have to do. And apart from that, there are the various kind of additives that are used in the lubricant. So lubricant is a very technical terms. Okay, when in the case of the fuel, when we have to see only calorific value of the fuel. Okay, and diesel, in the case of petrol and diesel, we have to see only calorific value. But when it comes to the additive, we have to see the several kind of properties. So lubricant do not play only role of the lubrication. It have to provide some other students want to join. Let them in. So lubricants had the various properties. Lubricants had to support, like I told you, it is a very chemical term, chemical and technical term. So now come to the non-Newtonian fluid. So how many? All of you have enjoyed the ice cream. Okay. So now I have a question that if you have seen that there's a water and there's a ice cream. So what is the difference between why we enjoy the ice cream and we do not enjoy the ice? Why? What is the reason between that behind that? Yes. Why ice cream? So when comes to the taste wise, you will say it is sweet. It is good in the taste. Okay. But as a mechanical engineer, when I go through the chemical non-Newtonian nature of the ice cream. You will find that if you will go in detail, you will find that ice cream is a non-Newtonian fluid. So that's why people enjoy. It's not like only non-Newtonian fluid people enjoy. It is pseudo-plastic lubricant. Ice cream has a property. If we apply the pressure on ice cream, its viscosity change. Okay, means on applying the pressure on ice cream, so ice cream start melting. So that's why we add a viscosity modifier in the ice cream. Okay, we make a natural. There is a natural chemical that is found from the seal. We mix with the milk and we made a ice cream. Okay, so ice cream में हम लोग basically क्या करते हैं? We add a viscosity modifier on applying the pressure. Viscosity of ice cream decrease and it starts flowing and people enjoy the taste. So similarly, non-Newtonian nature of lubricant is used in the machine. So various kind of lubricant they are at the state of solid, but when the pressure is applied, they become liquid and the flow started. A non-Newtonian fluid whose flow do not follow the Newton law of viscosity. So their property differ from Newtonian fluids. So most commonly viscosity of non-Newtonian fluids not dependent of shear rate or shear strain rate. However, there are some non-Newtonian fluids with shear dependent viscosity that nonetheless exhibit normal stress difference or other non-Newtonian behavior. Many polymer solution, molten polymers are non-Newtonian fluid. And there are many commonly used substances such as ketchup, custard, toothpaste. Toothpaste is one of example of non-Newtonian fluid. In paint, we add the polymers. From the polymers, it becomes non-Newtonian. Blood is characterized as a non-Newtonian lubricant. It is a different class of Newtonian fluid. In the blood, we have red blood cell, white blood cells, and various other suspended particles. So, blood is characterized as a micropolar lubricant. It is a special class of lubricant that is characterized as micropolar fluid. Ketchup, we have a suspensions of various solid particles. Similarly, custard in the toothpaste that is a semi-solid liquid. Okay, semi-solid fluid, starch, and another is a shampoo. Shampoo is another different that has the property of non-Newtonian fluid. Okay, so in shampoo you can see that when we apply the pressure starts the flowing. It will not flow the automatically, but when the ch apply, its viscosity decreases. But simply with the case of the blood is completely different. It has to carry various parts. So blood, if you will see, the blood is also play lubricant. So lubricant is also found in our human body, but those are the biological lubricants. As I told you, if there are two sliding surfaces, so definitely there is a wear. So if you will see the case of our human body, I'm audible? Yes.
Yes, sir.
Okay. So, like in our human body, we have various lubricant. Like our lubricant is called a synovial lubricant. Okay, like if there the two surfaces are sliding, then definitely there is chances that there will be wear. The machine will be worn out. It will not work. Like people say, what is the role of tribology in robotics, in electrical vehicle? So, role of tribology will not finish in that either it is electrical vehicle, either it is a robotics. Okay, if we will not design a robot by not if we will not take the proper care of lubricant, so joints of robot will be worn out. So similarly, nature is a very good engineer. So what if you will see our human body? So look, we have a various rotating parts. Our hands are in motion, always motion. Our legs are in motion. Our neck is also in motion. So our blood works as a lubricant. Our blood carries synovial lubricant. So it provides the lubrication our joints, our knee, our arms. So you can see that the generally senior citizen have the problem of the knee transplant. Fundamental reason behind that the lubricant between in the their body is finished. Okay, due to that, their knee joints are worn out, hip joints are worn out, so they have to replace that. Okay, so lubricant play a very important role in the life, in our life. It either it is a mechanical engineering, either they are the moving parts. Okay, so we have to design a machine carefully. You can design by using the stresses. You can design the machine for the stress. Okay, but if you want to improve the life of your machine, then you have to go. You have to study the trapezical. So maintenance should be less, and life of machine should be more. Then you have to go for the trapeze. Now come to the Newton's law of viscosity. So considering a 3D rectangular element of fluid like that in figure below. So Newton's law of viscosity is it is clear. Ch stress is directly proportional to the Ch time. It is clear. So we have taken a fluid element. Upper surface is moving and bottom surface is have a relative motion. Okay. Due to this relative motion, we have a difference in the stresses. Wait for 1 minute. Some students want to join. Let them in. So as I've discussed that this is a shear element. So upper surface is moving, okay, and bottom surface is fixed. Due to moving, the shear stress is developed. F force will act in right direction. So similarly, F force act in left direction. So shear stress is force divided by per unit area. So shearing force affects on the area on the top of the element. The area is given equal to del x into del z. We can thus calculate the shear stresses, which is equal to the force per unit area. So deformation which this shear stress cause is measured by the size of the angle F and is known as shear strain. In a solid shear strain, F is constant for fixed shear stress. T in a fluid F increases for as long as T is applied. The fluid flow. It has been found experimentally that the rate of shear stress CS stress per unit time, T by time, is directly proportional to the CS stress. So if the particle point E in the above figure moves under the stress, CS stress to point E dash, and it takes time T to get there, it has moved the distance x. That C, the deformation we can write that is tau equal to CS strain stress equal to the CS strain rate. This is called the fundamental Newton's law of viscosity. That is also you have studied in the fluid flow or fluid dynamics. So it is very useful in the study of lubricant. So as we are discussing that what is the difference between a fluid versus solid. So one more thing that we use the solid also as a lubricant and fluid as a lubricant. So when the speed of motion is slow, then we use solid as a lubricant. But if speed is very high, then we have to go for fluid as a lubricant, liquid as a lubricant. Okay, at a higher speed, we also prefer the gas as a lubricant. So there are some characterized solid. The strain is a function of applied stress, provide the elastic limit has not been reached. For a fluid, the rate of strain is proportional to the applied stress. The strain in solid is independent of the time over which the force is applied. Elastic limit is not reached. The deformation disappears when the force is removed. A fluid continues to flow for as long as the force is applied and will not recover its original form when the force is removed. Okay, so fluid is just a fluid can take any shape. Okay, so it is very simple to classify substance either as a solid. Some substance, however, pitch or glass appear solid under their own weight. Pitch will, although appearing solid at room temperature, deform and spread over time, days rather than the fraction of a second it would take water. So these are the some classification of Newtonian and non-Newtonian. So here, this is a very good representation that graph that you can see here in this figure. So you can see this one is a plastic. This one is Bingham plastic. This one is a pseudoplastic. So pseudoplastic, I told you, pseudoplastic are the example that I have given you. Pseudoplastic are the ice cream is a pseudoplastic fluid. Newtonian, like just water, most of the cases, we consider water as a Newtonian fluid, but it is not Newtonian fluid. And most important, this one is the dilatant, and this one is ideal fluid. So generally, we consider that a fluid is ideal fluid. We consider that this one is ideal fluid, this one is a non-Newtonian fluid. But generally, no lubricant is ideal fluid, lubricant is completely Newtonian. Okay, so they just due to this. So no lubricant is Newtonian, non-lubricant is ideal. So they follow the non-Newtonian behavior. So as you will see in the lubricant chemistry, we mix a lubricant with lot of component. Okay, non-Newtonian fluid. There are several category of these. Okay, like plastic. So we have to mix various kind of additive. So influence of those additive makes the lubricant non-Newtonian. In a pure form, it's to some extent every fluid, every oil follow the Newtonian nature. Okay, but due to the mixture of various things, its behavior becomes non-Newtonian. So this is example of dilatant, pseudo-plastic, Bingham plastic, and plastic. So CH, this is a graph of the CH test versus CH strain rate du by dy. You can see in this figure. So this is example of Newtonian versus non-Newtonian fluid. Each of these lines can be represented by equation tau equal to a plus b del u by del y and n, where a comma b and n are constant. For Newtonian fluids, a equal to 0, b equal to m, and n equal to 1. Okay. So here you can see that in this case, so this is the general representation of non-Newtonian fluid. So this equation they have to follow. Like in the various lab, when the lubricant is made, like IOCL develop, they they try to find out the value of A, B, and N. They used to find, but they do not reveal these value A plus B, A and B and N in the public domain because they have spent lot of dollars, lot of money, crores or arab of rupees. They are developing the lubricant. If they will reveal these value of these coefficient, so public will know and they are able to manufacture this lubricant. Okay, so they do not reveal any company. They just give a viscosity index at a particular temperature, viscosity, and nothing else. So lubricant is a very big industry. People are doing research a lot. They are developing various things. Okay, but it is not revealed in public. So this is some classification between non-Newtonian and Newtonian fluid. Like we have to characterize when we are doing a research. So plastic. So CS test must reach a certain minimum before flow commence. So there will be a question on the basis of these slides in your exam. Okay. So there is one question related to Newtonian and non-Newtonian fluid. Bingham plastic as within the plastic above a minimum CS test must be achieved with a classification n equal to 1. So if n equal to 1, so this is characterized as Bingham plastic. Okay, in the plastic CS test must reach a minimum level before the flow. So this is example of Bingham plastic. We have to first apply the stress, then only flow start. So in pseudoplastic, no minimum CS test is required to flow. Okay, and viscosity decrease with the rate of shear colloidal substance like clay, milk, and cement. So dilatant substance viscosity increase with the rate of shear, e.g. quicksand. Thixotropic. So viscosity decrease with the length of shear force is applied. Thixotropic jelly paints are some example of this kind of lubricants. Then the rheotropic substance that viscosity increases with length of time. Shear force is applied viscoelastic material similar to Newtonian, but if there is a large change in the shear, like behave like plastic. So there is also one more which is not real. It does not exist, known as a ideal fluid. This is a fluid which is assumed to have no viscosity. So this is a useful concept when the theoretical solutions are being considered. It does help achieve some practically useful solutions. So liquid versus gases. So now come to the liquid versus gases. So they are also used as lubricant. Gas is a very good lubricant at a high speed. When we have to run our machine and lakhs of RPM, then we have to use gas as a lubricant. Okay, gas has some good properties and some bad properties that I will discuss later. So a gas is given mass or liquid occupy a given volume and will occupy the container. Okay. So as it is useless to discuss here what is the difference between liquid and gas from the substances level. So I will skip this slide. So cause of viscosity in fluid, so that is very important thing. So because viscosity in gases, the molecules of the gases are only weak, only weakly kept in position by molecular cohesion, and they are so far apart. As additional layer move by each other, there is a continuous exchange of molecules. Somebody wants to join, let them in. As the adjacent layer moves by each other, there is a continuous exchange of molecules. Molecules of a slower layer move to faster layer, causing a drag, while the molecules moving the other way exert an acceleration force. Mathematical consideration of these momentum exchange can lead to Newtonian law of viscosity. If the temperature of a gas increases with the momentum changes between layer will increase, thus increasing the viscosity. Viscosity will also change with the pressure. But under normal condition, this change is negligible in gases. And one more thing, temperature viscosity is a directly function of temperature. So the momentum exchange between layer will increase the increasing viscosity. Viscosity will change with the pressure, but under the normal condition, change is negligible in the gas. So viscosity in the liquid is a non-linear function of temperature. But on the increasing of temperature, viscosity is drastically decreased. Okay, on increasing the temperature, viscosity becomes half. So here you can see the mu naught equal to 1 plus AT plus BT. So you can see these coefficient A and B, they are always negative. So there is a molecular interchange between the adjacent layer in liquid, but as the molecules are much closer than in gases, the cohesion force hold the molecule in place much more rigidly. This cohesion play an important role in viscosity of liquid. Increasing the temperature of fluid reduces the cohesion force and increases the molecular interchange. Reducing the cohesion force reduces the shear force, while increasing the molecular interchange increases the shear stress. Okay. So now come to the again. This was a diagram that same we have discussed that Bingham plastic, pseudoplastic, dilated fluid, Newtonian fluid, shear rate. Okay. So I want to discuss that. Are you able to getting about this course? Yes. Any query because you do not ask any question. I expect that you will ask a question because this is a very practical course. And in the last semester, I expected that one is a mathematical course. So you have a difficulty in understanding. Yes.
कैसे करते कभी ज्यादा है कुछ ये तो हो जाना था जल्दी
Hello. Hello, Jean. Yes. Any question? Jeel Patel, Kapdi, Dhurvil. Yes.
No, sir.
क्या
No any query, sir.
ये कोर्स पूरा समझ में आ रहा है? हम्म
Yes, sir. वो ऐसे मोर पढ़ा हुआ है ना तो समझ आ जाता है बेसिक.
अच्छा, कोई दिक्कत नहीं है इसमें. ठीक है, I hope that you are getting everything clearly. So now come to the type of lubricant that we have discussed. Now come to the some example. So like viscosity, viscoelastic lubricants, like on the basis of non-Newtonian. So Kelvin material are viscoelastic example of the viscoelastic. Okay, elastic. So parallel linear combination, time dependent, rheotropic, thixotropic. So apparent viscosity increase with the duration of stasis. Some lubricant, weaved ice cream, and thixotropic example of apparent viscosity increase with duration of stasis. Some clay, some drilling mud, and many paints, synomical fluid, honey are the example of thixotropic lubricant, thixotropic fluid. So time independent shear thickening, shear thinning. Shear thickening is a dilatant, shear thinning is the pseudoplastic. Apparent viscosity increase with increased stresses in dilatant. If you increase the stresses, then viscosity will increase. And in the pseudoplastic, if you will increase the stress, viscosity will decrease. The example of ice cream. Okay, like water, latex paint, and blood, syrup, and general Newtonian fluid viscosity is constant with respect to stress, depend on normal station rate and pressure applied on it. So nowadays, this lubricant is quite developed. Various researcher, electrorheological lubricant, electrorheological fluid. It is used in machines. So property of this lubricant that on increasing the on adding the electrical field, its viscosity changes. So this kind of concept first comes the suspension. Like we have the electrorheological suspension systems. Okay, so if you have seen the shock absorber that they absorb the vibration, but okay, so by changing the viscosity, we can change the magnitude of damping. Similarly, if we apply an electrical field, we change the rheological behavior with respect to electrical field. And because the presence of electrical field, a significant change occurs in the viscosity and pressure. This is due to the formation of change particles and which resulted transition from Newtonian to non-Newtonian behavior with higher effective viscosity. So this one is the equation of electrolytical fluid. This is the mathematical form of continuous being a model in dimension forms. So it gives the relation of shear strain rate and apparent viscosity. So these are the some fundamental property. Okay, E by V. So therefore, definitely question related to the this rheology. So this is the some parameter like viscosity properties that we have discussed. So viscosity, how if it affects. So viscosity measure the flow resistance or lubricant resistance. Viscosity of lubricating oil determines its performance under the operating condition. A low viscosity oil is thin and flow easily. A high viscosity oil is thick and flows slowly. As oil heats up, it becomes more viscous, becomes thin. Too low viscosity of the liquid lubricant film cannot be maintained between the moving surface, excessive wear. Too high viscosity of the liquid, excessive friction, and selected lubricant must be proper viscous. Viscosity usually expressed in terms of centi-stroke and centipoise. So this one is the parameter to calculate the viscosity index. So it is average decrease in viscosity of oil per degree rise in temperature between 100,000 Fahrenheit to 210 Fahrenheit. Viscosity of liquid decrease with increasing temperature. The rate which viscosity of lubricant change the temperature is measured by a scale called viscosity index. Silicones, polyglycol, ether, diester have the high viscosity index. To determine the viscosity index, first the viscosity of oil under the test is determined at 100 400 to 10. Let it be U and V. Then the viscosity of penicillin oil determined let V and H. Then the viscosity of Gulf oil determined let it be PL and viscosity index VL minus U, VL minus H. VI equal to 100 penicillin oil in the thermic base Gulf oil. Higher the viscosity index, lesser is the variation of viscosity with change in the temperature. There is a good lubricant oil should possess high viscosity index. So next is the iodine number that we will discuss in next class. If you have any query, please let me know. Yes.